So at this point, we can basically stop our debugging. And so this clearly demonstrates the fact of life that essentially the moment you add in a pointer or a reference to your classes, and so they indirectly access something else outside of their own scope. Like here we had those, two Terminator instances having access to one integer and another integer. The rule of thumb is that you may as well add a copy constructor and do something useful, because you really need to resolve this situation. The default version of copy constructor that is given to us for free simply makes an exact copy of Alice, and therefore you have an exact copy of this MPTR inside of our object, and therefore Bob refers to the same integer in memory, and this is called shallow copy. This second version creates a deep copy, which guarantees that each instance of the Terminator refers to a unique integer, and if you want to create copies of them, right, that's not a problem. You can do that. We will provide control over that by providing the copy constructor, which will happily do its own thing, and by design it will be doing something to keep things in good order, so that each Terminator has a unique integer to point to, and if it wants to delete it at the end of its life cycle, that's okay. It should be allowed to do that. All right, so it's a little demo here, copy constructor example. So going back just to discuss the syntax, right? So copy constructor example, if we have a point class, then if we want to add a copy constructor to it, so we simply declare it like this. Again, you use reference to prevent copying of arguments but still have access to another object. You need a reference as an argument to your copy constructor. This is really where the reference really shines and allows you to essentially avoid copying, but not requiring the client code to deal with pointer semantics, because references can be initialized very simply with original objects. And that's exactly what is happening here, right? Bob copy constructor does get access to Alice, does it indirectly, but this line doesn't even mention it, which is the way the copy constructor is using a reference right here in its parameter, right? This can be done like this, but again, it's advisable to use with straightforward initialization like this, use initializer syntax as opposed to function call syntax when constructing a copy of another object. Any questions about this? I know it could be a little unsettling to see so many different connections, but this is really where the need for copy constructor is arising, and we're trying to justify that we want to be able to control the way objects are copied, and we want to control everything that happens during copying. However, if you want to ignore it, then you get a free version. A free version just does bit by bit initialization of every single piece of your object, and you get exact copy. This may not be exactly what you want, but it's free. But once you add a copy constructor, you can control it. So then, if we declare by the way, in our example, all of the code was written in line. So instead of just declaring and providing an implementation file, I was using, I was writing code in line, just like Java style approach, right? So it's possible to write it this way. However, in some cases, it may be difficult, and not everything becomes available with this syntax. So this is called inline implementation, directly in a header file. Remember, this is a header file. So an alternative to this would be to just go back and declare a copy constructor and then define it in the implementation file, and then the implementation file, of course, needs to be added to our project so that we have another source file that needs to be compiled, and it may provide the whatever work it's doing. By the way, this copy constructor is completely useless because it already does what the default constructor does. So unless necessary, don't add copy constructors just because you know you can add them, right? But as soon as you need to tweak things around, and that especially is important when your classes have pointers internally as part of their implementation, then you obviously add them. So calling copy constructor is simply by doing this, or I'll have another example right here. I could have a function, I don't know, void foo. I don't know what that function is, but it takes the terminator. Takes the terminator, right? Terminator TRM as a parameter, right? So, and it does something. Clearly, this TRM thing needs to be, initialized when I call it. So, I don't know, we can do something. I don't know what. So, if I want to call function foo, then I would have to say, okay, foo, take, make a function call and take Bob as parameter, right? So obviously, copy constructor will be invoked because this function says, I want an instance of a terminator, please. And so the function call provides an instance of a terminator named Bob. On the next line we could call foo with Alice, right? Because we have yet another one, so we could call it with Alice. And each time a copy constructor will be invoked to manufacture a copy of all of these. So our terminator copy constructor will be invoked every time we call foo, right? If that's not what you want, then use indirection, use pointer or reference. That way you're saying, okay, it's still okay to call foo just like this, but look, the TRM will be using reference to the original Bob and original Alice in this function, right? So here, this is copying. This is no longer copying, but taking a reference to the original. Agree? Right? So, and it's called type modifier. This is no longer address of operator. Remember, right here, someplace, not in this example, but if you use ampersand of an applied to an object, you're obtaining the address of an object. When the ampersand is used in a declaration, this is just a recycled ampersand punctuation character in order to give you a type modifier, which makes TRM not an instance of a terminator, but rather a reference to a terminator existing someplace else. And you must provide it in order to initialize this reference. And so we do as function parameters. Okay, so these are simple rules, and you can see that a reference is very much like a pointer. But in our copy constructor right here, see how I'm using my reference, and I'm saying if another object contains a non-null pointer to some integer, I'm actually going to go into that object and grab the value from that pointer, dereference it, and assign it to my brand new integer as well. So as a result, you know, if this had 1, 2, 3, 4, 5, the result of this copy constructor is that this one also will have 1, 2, 3, 4, 5. So the value also will be copied, right? Now, let me save this.